Do you find the balancing of nuclear equations very difficult? If yes, then today I'm going to take you through how to balance nuclear equations. Hello, welcome to Chemistry Made Easy. If today is the first time you're watching this channel, I urge you to subscribe, like, and share. We want to look at how to balance nuclear equations. So let's get started. And before we balance nuclear equations, there are some particles or subatomic particles that are of known mass numbers and atomic numbers. So we have to see those particles. So for example, if you have an alpha, it is denoted by this sign, that's a mass of 4 and an atomic number of 2. It is also similar to the helium nuclide. So an alpha particle can be seen as an ionized helium. Now we have a beta. Also sometimes regarded as electrons. So the beta particles have the sign with a mass of 0, a charge of -1. And the electrons also have similar mass number and atomic number. Then we have neutrons, denoted by N, a mass of 1 and an atomic number of 0. Then we have protons, or normally seen as hydrogens. So protons can be denoted by 1, a mass of 1, an atomic number of 1. Then the hydrogen, it has similar mass number and atomic number. Then we have positron. For positrons, they have a mass of 0, a charge of +1. Then we have helium, which I've just stated here. So these are the common particles with their mass numbers and atomic numbers. So when you are balancing nuclear equations and then you see any of these particles being mentioned or it is being written in an equation, you should know what their mass or their atomic numbers are. Now let's take an example. We're saying that when we want to balance, now let's take an example. We said that when you want to balance a nuclear equation, nuclear equations can be given to you in two forms, sometimes in word form, or they will give you the equation and then they'll ask you to balance it. Okay, so we're going to take two examples where we are going to be given a word equation and where we will also be given just an equation and then we will be asked to balance it. Now, but before we balance nuclear equations, there are two laws that help us in balancing nuclear equations. We have what we call the laws governing balancing nuclear equation. One of those laws is what we call the conservation by mass. And the next one is the conservation by charge or atomic number. Now, what the law of conservation by mass states is that that the sum of your mass numbers at your reactant side, which is your left-hand side, should be equal to the sum of mass numbers at the product side, which is your right-hand side. And the law of conservation by charge or atomic number says that the sum of charge at the reactant side is equal to the sum of charge at the product side. So these are the two laws that govern balancing nuclear equations. So let's look at an example. So an example 1. The reaction of an alpha particle with magnesium 25 produces a proton and a nuclide of another element. Find the other nuclide. So here, solution. We're told that an alpha particle with magnesium 25. So it means that when magnesium 25 reacted with an alpha particle, that is produced is a proton and another element. We don't know that element, so we assume that element to be any variable. So let's say we are using x. Then we assume any variable for the mass and then the atomic number. So after writing out this expression from this statement, we will now use what we call the first step, our conservation by mass. So we are going to sum up our mass numbers, so 25 plus 4. Then we'll sum up this one plus A. So we have 29 is equal to 1 plus A. We will have A to be equal to 29 minus 1. So we're going to get A to be equal to 28. Then we apply the conservation by charge. So we sum up our charges. 12 plus 2 will give us 1 plus Z. So 14 is equal to 1 plus Z. Z will be equal to 14 minus 1. Z is equal to 13. So we have identified both our mass and our charge. So we can now have our equation as so we can therefore conclude and say that we are asked to identify the nuclide. So based on the atomic number of X, we can identify the nuclide. So X 1328 would be equal to aluminium, since that is the one with an atomic number of 13. So this is how we balance nuclear equations. So this is a word equation. Let's take another example. So example 2, we're asked to balance the following nuclear equation. J (82,285) plus 2 into bracket P11 to give us AST plus HE24. So we are going to use the conservation by mass. So we are going to sum up our mass, so this will become 285 plus 2 times 1 will give me 2 is equal to S plus 4. This is 287 equals to S plus 4. Our S will be equal to 287 minus 4. S is equal to 283. Then I'll use conservation by charge. So I'm going to sum up the charges. 82 plus 2 times 1 will give me 2. T plus 2. 84 is equal to T plus 2. So T will be equal to 84 minus 2. T is equal to 82. So now I can conclude by saying that my balance equation becomes 28582J plus 2 into bracket 11P. Then we have 283 and 82A plus HE24. So this becomes our balance equation. But if you want to be sure, you have to make sure that you sum up both the mass and the charges. The sum of mass at your left-hand side should be equal to the sum of mass at the right-hand side. The sum of mass at your charge, the sum of charge at your left-hand side should be equal to the sum of charge at the right-hand side. If it is so, then that means that that is a balanced nuclear equation. So this is 285 plus 2, that's 287. 283 plus 4, that's 287. 82 plus 2, that's 84. 82 plus 2, that's 84. So that becomes a balanced nuclear equation. I hope you understood this lesson. If you did, I urge you to subscribe to my channel and then hit the notification button.